In today's lecture, we will try to know some concept of DFD, some symbols used in data flow diagrams, block diagram of DFD, rules of DFD which are very important while drawing the diagrams, one context level data flow diagram, and finally one example of how exactly we should construct our DFD. So let's get started. So on screen you can see some of the symbols which are used in the construction of data flow diagrams. As the name is suggesting, data flow diagrams help us to give the flow of information or how exactly data is processed from start to end in any system. DFDs are by far used in explaining or in construction of any system, but particularly in the construction of softwares or systems. We can draw DFDs in the initial stages of our software construction or development of software. We already are familiar to what system development life cycle is all about, what is SDLC, what are process models of software engineering which are evolved from SDLC. So while the construction of any software, we follow some initial stages of requirements gathering or requirement anticipation or requirement specification. So after we try to finish our first phase of collecting information or requirements, the next step we head towards is drawing data flow diagrams, which actually help us to get a clarity on what exactly our system will be, and at the same time explain others, our teammates or even customer, what exactly or how exactly our system will evolve. But while drawing DFD, there are two types, or you can say there are two methods to construct data flow diagram. One is used to actually explain the manual working of existing system, like how exactly now the process is going on, or what is the manual flow of work, how exactly information is getting generated, how it is traveling from one source to the other destination. And the second type is drawing DFD to explain how exactly our software is behaving. So there are two types, there are two stages, you can say. In fact, the first stage, that is where you explain the manual working of any system, is very important. First, for the developer to understand what components, what modules his system should have, and at the same time to get a clarity on what modules we should concentrate on, and to understand the working or flow of information. And finally, when you complete your system, it is when you have decided all the modules, you are done with the coding, you're done with the testing, and you're heading towards the acceptance testing. This is the time when you want to explain the final software. This is the time when you redraw your DFD, and then this time you will explain the working of your software. But first, we should try to understand what exactly our software or project should have, how the information should flow from one component to other, which is very easy once you understand these symbols. So as you can see, there are by far maximum 4 symbols used in drawing DFD. There are two types of symbols, you can say. One is Jordan symbol and the other is Gain and Sarsen symbol. But both the count of symbols is same, the meaning of symbols is again same. The first symbol which is used is process box. As the name is suggesting, this symbol is used to show any process which takes place in your system. So let us first discuss the Jordan notation, or you can say Jordan symbols. Process box is drawn inside a circle with a compulsory partition of process number and process name. These are the compulsory things. These are notations. Try to follow them as it is. Don't make any changes in the size and shapes so that you don't violate the rules of drawing diagrams. The second is entity or source or destination. So usually whatever entities are coming in your system should be drawn inside a rectangle and should be labeled. They should contain the entity name inside them. Next is data store, or they also call it data storage. So as you can see, there are just two parallel lines drawn here, and data stores, as the name is suggesting, are storages. So if you think in your system there are certain storages, those can be godowns, those could be products where the products are stored, those could be cold storages if it is applied to your project. These are something which are materialistic storages. The second type, or you can say the second part of storage, is where you have your manuals, or you can say if your system contains certain registers, certain musters, certain bill books, some documents are generated, some inward and outward documents are kept. These things should be kept inside the storage symbol, and the symbol used is just two simple parallel lines. The next are data flows. As we need to connect all of them together to one another, we need some connectivity. So simple arrowheads are used and we have to label them. So if you're making use of DFD which are not having any labels, it will not give us clarity on what data is processing, what information is going in, and what information is coming out. You can either use straight lines with arrowheads or curved lines with arrowheads. I haven't shown the arrowheads, but if you're making use of these curved lines, do not forget to add arrowheads which are unidirectional, not bidirectional. I have gone through many data flow diagrams which sometimes show bidirectional arrows, which is not correct. You need to be specific while drawing your data flows, and you need to have some flow of sequence of information. So first, if the information is going in and it is getting processed and some information is going out, make sure you make use of two different arrows and not bidirectional. So these are the Jordan symbols. Similarly, we have some gain and Sarsen symbols, which are again same working, or you can say same meaning, but the shapes are changed. As you can see, Jordan made use of circle, Gain and Sarsen has made use of square but rounded corners, again with a partition of process number and process name. Second symbol used in Gain and Sarsen to explain the entity, which is either source or destination. The entity can be something from where data is getting in the process, so it will become the source. Process box is going to process that data and give it back to someone or some other entity, so that becomes the destination. Similarly, in Gain and Sarsen, if you are making use of entity symbol, it should have an elongated rectangle. Here it is the normal rectangle and here it is the elongated rectangle. Next, data store or data storage should make use of two parallel lines but with the partition of storage number and data store name. Flow lines in Gain and Sarsen are denoted using half arrows and again unidirectional. You cannot make them bidirectional. They are half arrows with unidirection. So these are in totality the symbols which we are making use in drawing DFD, manual DFD, or even to explain the automated computerized system. Now let us try to understand how to put all of them together and then construct one DFD. So this is one block diagram of data flow diagram. Many times sources are kept in the left hand side, destinations are kept in the right hand side, information goes in from source to process, it gets processed and output is given back to the destination. If it is not possible for you to maintain this flow, that is information going in the process from left hand side getting processed and going out as output on the right hand side. No need to worry, you just place it according to your convenience, but make sure the incoming and outgoing arrows are correctly placed. At the same time, if you want to just show the storages, you can show two different arrows of some process information going in the storage. And again, if we want to refer it back, like if it is a bill book, we will be writing down the bill book, and at the end of the week, if we need to check what was the total number of sale, we will go through the bill book again. So it is the two-time reference. So in such cases, you need to refer them twice, make use of two different arrows and place them correctly. One more thing which you should avoid doing is don't place any of the sources on top. As there is a partition for process number and process name, above the partition, try not connecting any entities. So don't connect any entities on the top. And again, you can surround the process with any number of entities you want. So this is the block diagram of DFD. Further, this is block diagram of context level DFD. Now what are context level DFDs? These are the DFDs which show the total overview or working of any system. Once I go through the context level DFD, I get the complete overview of any system. So you can place your sources, you can place your destinations as per your convenience. And one thing which you should note is these data stores, which are storages, are not shown in the context level DFD. So you should avoid showing data storages in context level DFD. Once you're going to increase the level of DFD, we will be dividing one DFD into its smaller processes or sub processes. At that time, you can definitely show your data storages, but in context level DFD, try to avoid it. So these are certain rules of DFD which should not be violated. You should completely follow all the rules. Now let us go through the rules which should be followed first. Data should flow or can flow from external entity to process. That means from here it can go inside, you can connect them. Process to external entity, that means from here to the entity. Process to store and back, which was here. So from process you can connect the data store and again data store to process. Process to process. So if you're increasing its levels, this is context level DFD and it will have only one process. But now if you're taking it to next level, you will be increasing the processes. You can connect two processes together. So this is the things which we should follow. Now let us go to the things which we should avoid doing. First thing is data cannot flow from external entity to external entity. That means you cannot connect two entities together. For showing the relationship between two entities, we have ER diagrams, but in DFD, you should not connect them together. So make sure you follow this. From external entity to storage. So if you're making use of storages, you cannot directly connect store to entity or entity to store. There should not be a connection directly. There should be a process between two entities and between two storages. So data should flow like this. Further, you cannot show data flowing from store to store. So if you have multiple storages in your system, you cannot directly connect them. You need to have one process between them. So further we have the diagrammatic representation of the theory which we just read. Two entities cannot be connected, two entity and storage cannot be connected. Storage and storage cannot be connected. We should always have a process in between them. So when you think of increasing the levels and getting into the deeper side of data flow diagrams, it goes on increasing from level 0, which is the context, which is compulsory. While drawing DFD, you should first draw the context diagram, which should give overview of your complete system. Then you will reach level 1, which is going to give you overview of the diagram with one level expansion. Next, level 2 is going to be detailed diagram of level 1. So from 0 to 1, when we head towards from 0 to 1, we slightly go into the detailed or deeper side. When we head towards from level 1 to level 2, we actually split the level 1 processes into smaller sub processes. This is how you understand how many modules your project is going to have, how many modules your software is going to have. So there is no such rule that how many levels should any DFD contain, or how many entities minimum or maximum my system should have. There is no such restriction in drawing DFDs. You can have as many entities as you want, as many levels as you wish. So again, let us go through the context level diagram rules that it should have only single process box. It should give complete overview of any system. It should define the scope of the system. It is actually the black box concept. Black box is when you just give input and check output. You don't know what exactly is inside the system. So it is also known as black box concept. Labeling always 0.0. Context level diagram should be always labeled as 0.0 and no data storages. So these are the certain, or you can say, rules of context level diagram. This is the block diagram of context level DFD. So here you can see there is a source, there is our process box, there is our destination. This is the thing which I was trying to explain you. So if it is getting difficult for you to place the sources and the destinations, make sure that you take your entity, show the arrow properly with the arrowhead, label it correctly, get it processed, feed the information first, process it, and get it back as output. So you can have as many arrows as you want from the source and get it processed, and also at the same time it becomes destination. So do not keep in mind that the information flowing in should be treated as source and the destinations are something which is receiving. You can have some entities which get it back quickly, so you can have it by making use of arrows. So this is one simple diagram which I have tried to draw, the most simple one to just explain the context level or zero level DFD for college admission system. This is going to be detailed when we go through the next example. This is a simple one. So here we have an applicant which is filling the application form and feeding it in the college admission system. It is college admission system is giving fee structure to the applicant, and applicant is trying to pay the fees. On the other hand, if you can see, the other side is office management of college. So one side is for the applicant and the other side is for the office and management. Here the fee structures are decided by the office, batches of students are done by the office, and system in return is giving them back reports. Now this, if you go through this DFD, this is not manual DFD which I just told you. One could be manual working and the other could be explaining the software working. So this is the software's working, where applicant is filling the form, just referring the fee structure, paying the fees through by making use of payment gateways. Office is in return or is deciding the fee structure, which is referred by the applicant here, is making the batches and viewing the reports. Everything is getting processed in the process box. So this is the automated DFD example. Now let us check how to draw a manual DFD. So once you are into the construction of software and you're just going through the phases, the first phase is requirement gathering and requirement analysis and specification. So in this phase we actually collect information in a vague format. It is miscellaneous. We are not sure which information should be treated as the vital or the important one, which information should be excluded. Everything is in confusion. So we just go and collect the information by having a conversation with our customer or end user, and this is how we collect it in a miscellaneous form. So right now I've picked one example for restaurant management system, and I have just sat down and just written the things which came in my mind. So you can see there are certain persons here, there are some infrastructural things, there are some things which are related to kitchen. So everything is in mixed format. So this is where your DFD is going to help you to just bifurcate, divide the things in a beautiful manner, and then arrange them in a diagrammatic thing, which will give you one overview of how exactly this manual system is working, and then go to the automation. So the next step is, once you just sit and write all the terms which come in your mind, the step 2 is to just bifurcate them and collect them in a manner if it is possible. So try to classify them, try to group them together and just separate them out. So here you can see I have just separated some things. Still it is in a miscellaneous form. I haven't got a complete overview. I haven't found a complete, you can say, hint or shortcut now to draw DFD. It is still in a mixed format. Now the step 3 is, step 1 was writing it down in a mixed format. Step 2 was collecting them together, and if it is still getting difficult to collect, now follow the step 3 and group them. So I see customer, I see chef, waiter, manager, supplier, cleaners, employee. So you can now think on what symbol should I use to depict them. So customer cannot be a process. Chef cannot be a process. A process is something which is having, taking some information or taking something, making some changes to it and producing something. So this is known as a process, and these are not processes. In fact, these are the entities. So objects or persons or people which come into your system and give you, provide you some information, are entities. So these are my entities. Further, I see there is transport, I see there is kitchen, there is delivery. Now if you check, transportation involves loading, unloading, traveling, buying. So once you buy something, you load it into your truck or any vehicle you have and you unload it. So this is a small process. In fact, kitchen is the most important process in restaurant management system. So here you actually get raw things, process them, prepare some lavishing dishes and serve them. So this is the most important process of our system. Finally, there is delivery. If you have parcel or delivery system, people are going to come to your restaurant, or you are going to hire some people like Zomato or Swiggy, or you can make use of an outlet, a small outlet where you can give away your takeaway parcels. And delivering is again a small process where you carry the parcel, deliver to the right people and get the payment. Again, we have bill as the most important process where calculations are involved. So this is how you can sit and just group them and just separate them together. Now at least, while context we will have only one process, but when we will increase the levels we will get multiple processes. So this is how you should go on. Now let us draw the diagram. We will start by drawing the process box first. Always make sure you place it centrally and keep a right amount of space from all the sides. The top space we are not going to make use of, but the rest of the space we are going to utilize. So we will give the name of the process inside the process box. Further, we will place our entities. Right now I have taken 3 entities. You can go on and have as many entities as you want, but for my simplicity I have kept it to 3 so that I can explain you. Next is connecting them with the proper flow lines. Bi-directional arrow. No, you should not make use of bi-directional arrows. You should always make use of unidirectional arrows. So just arrow head should have only one arrowhead, and do not forget to label them correctly. So here I have just drawn one arc and I have written displays menu card. So definitely the restaurant is going to display the menu card to customer, properly arrowheaded. Next, customer is going to place the order. Restaurant is going to serve the food. After it serves the food, the customer will have the food and restaurant will generate the bill. And finally, customer is going to pay the bill back to the restaurant. Now, one side of DFD is completed. Let us head towards the other side. Here, purchase order is given by restaurant to supplier. Supplier in return is going to supply the goods. He is going to generate the bill, whatever he has supplied to the restaurant. Restaurant is going to pay back to the supplier. So this is how we have completed the other part as well. Now let us complete the third entity. Employee is going to give the total sale to restaurant. Employee is also going to give total working hours. If the salary is getting calculated on the basis of working hours, he will have to give the working hours. Further, restaurant is going to pay the salary. So this is how you should draw your context level DFD. Now again, you can have a difference of opinion that this is still not detailed. We need detailed working. This is where we head towards from context level to leveled DFD. Then we will actually divide one process into multiple processes and then connect the entities properly to as many processes as you want. So this is how the context level diagram gets constructed. Still, it is the manual working. Now I understand that if I want to automate a restaurant management, I need to keep some space, some tables, some, you can say, form, data entry form, where I can keep customers information. I should keep supplier information. I should keep employee information, and then the other informations should go get processed inside my system. This was all about drawing DFD and context level diagrams. So I hope it was easy to understand and was helpful. Thank you.